Hi everyone, good morning, and thank you for joining us on this webinar, Gain Insight with Imagery in ArcGIS. Just before we get started, we've got some housekeeping. The webinar today will be recorded and we will share a link in the follow-up email, which will also include links to helpful resources. And we also run a Q&A at the end of each session, and you can submit a question via Slido using the joining details on the screen now. At the end of the session, we will answer as many questions as we can during our time, so please do submit any questions that you have as we move through this session. So a little bit about us. Hi, I'm Claire. I'm the Product Communications Manager here at Edge UK, and I'm joined by my colleagues Mark and Arthur. Mark is a customer success consultant working in our pre-sales team, and Arthur is a GIS consultant in our professional services team. Mark and Arthur are joining me today to share demonstrations throughout the session. We'll kick off with an introduction to imagery in ArcGIS, and then we'll touch on three key elements: reality mapping, analysis and observation, and spatial pattern detection. And then we'll finish up with that Q&A at the end. So if that all sounds good, let's just jump in. So to kick off today's webinar, I wanted to show you a concept application that we shared at our recent conference in London. So this is Irvine. It's a coastal town in Scotland, and it's well known for being one of the most prominent ports after Glasgow in the 16th century. We're looking at it through an app called DTM Explorer that was developed by our research team. So currently at this view, it's not telling us too much about the landscape and its history, but I can use this app to quickly and dynamically explore the elevation using the data sliders. So if I start to reduce the ramp from its maximum on the left, our perspective on the landscape starts to change, and we can see all the detail revealed in this area. If we look a little closer, these little donut-shaped features appear. My colleague Matthew, who built this app, discovered that these little donuts belong to Alfred Nobel's first UK dynamite factory. It's derelict now, so what we're seeing is the mark that it's left on our landscape and what history tells us about this factory's role in this once bustling port. I think this is a really great example of what we can see when we look at our world from a different perspective, what we can learn about our history, and what insights we can uncover with what we can't see with the naked eye. And we can even make predictive models about our future. And this is all because today we have more sources for imagery and other remotely sensed data than ever before. From aircraft and drones, satellites, mobile mapping systems, CCTV cameras, there's a growing number of sensors that we can leverage to collect this imagery data. And what's been really prominent for me is that we're seeing a stark rise in the popularity and the application of drones in particular. They're more accessible, more affordable, more user-friendly than ever before. And with the advent of multispectral and thermal technologies, it's enabled us as GIS professionals access to capture data beyond the visible spectrum, providing valuable insights for environmental monitoring, agriculture, urban planning, and much more. And if you don't have access to a drone or your own imagery, then we have a fantastic network of partners here at Edge UK that we can work with to help source imagery that works for you and your use cases. And so what we'd like to share with you today in this webinar is how the ArcGIS system is well placed to integrate with all types of imagery. It offers us a comprehensive imagery system, and this all starts with our data, whether that be your own data you've collected from a drone perhaps, data from the Living Atlas, or indeed from our partner network. And once we have that data, ArcGIS is pretty much our oyster from this point. So today I'd like to step through just 3 examples of recent imagery advancements for imagery in ArcGIS. Up first, reality mapping. So we can use reality imagery to perform reality mapping to create accurate site models, base maps, and other foundational content. And to show us some of this in action, I'll hand over to Mark. So Mark, over to you.
Thanks, Claire. I will get my first slide up. Are we seeing that? Reality mapping. So hold on to your seats. We're going to get through this in about 8 minutes, but you will get an understanding of something called photogrammetry. And if you know that already, I'll show you a whole lot of examples of how we can exploit it. But what this is really about is making a digital twin. And it sort of democratizes, or I'll show it democratizes the use of this data. We're not waiting for big satellite organizations or national mapping agencies. But just before I go through and show you actually how we make one, let's just look at a couple of examples. So here I'm using just a browser, the 3D scene viewer that you'll see in ArcGIS Online. And we're looking at a reasonably high resolution digital twin, very small area, 60 meters by 60 meters. This was flown for our sort of EOD customers who are looking at getting a robot down one of these roads. And it was interesting because top down, what you wouldn't have seen was that pole there, which the robot probably would have driven into. But in terms of use cases, local government might be interested in the state of the cattle grid there, or potholes, identifying potholes. We might be using computer vision for that. But let's just move through to another use case, another example. Monitoring the state of the forests, so looking at the state of the trees, measuring the street height and so on. And again, very quickly on to another example. And this is a linear feature, so it's not a river, it's actually the Basingstoke Canal. So again, perhaps a tree coverage, the state of the banks. In the military context, which is where I mainly work, how do we get across that river? How deep is it? What can we actually do there? And then another example. This is Loch Derg. It's a place called Dromineer in County Tipperary. And what we're seeing here is an ancient monument. It's a 13th century castle. So we get a view of what that looks like and the surrounding buildings and so on. But what I would say is most of you have never been there, but already we're getting a good understanding of what this like, what this thing's like, the port that's in there. And really, in terms of this baseline digital twin, that's what we're getting. Myriad of use cases, you're probably thinking about that already, but we've never been there and we're getting a better understanding of it. One just very quick last example. This is the Royal Engineers Museum in Chatham in Kent, and we've got a high resolution model there. And we're just adding some associated data to give us context, some level 1, level 2 detail buildings there, so we've got context. Let's go back to the slides and just look at now how we actually get that done, and really, why is this drone flying around? You can see the modalities there. Claire's mentioned space-based assets, satellites, air-breathing aircraft, and the sweet spot, which we're really talking about here, is the use of drones. And it's, again, about low cost and low latency in a temporal aspect. We can deploy these drones very quickly. And in the graphic there, you can see a drone coming out of a box. This is here at Tech 8. So we don't even need a pilot near there. We can deploy these. But ultimately, the drone is actually just taking pictures and videos. Just sort of think about that, and we've got technology for that. Let me just sort of bring it back to pictures. The videos are a subject of a different presentation, but what's happening is the drone is taking lots and lots of pictures, and this is where the photogrammetry piece comes in, because we're taking pictures with a high degree of overlap, typically 60 to 70, 80%. So one single point may have 5, 6, 7, 8, 9, 10 images of it. And what's happening is the photogrammetric engine, and this is reality, is identifying tie points, same place on the image again and again and again, and it's triangulating it just like our eyes do. And we're able to build up this model and then drape the images on top of it. That's what the photogrammetric engine does. And that's a very simple explanation. The maths, you did matrices at school in mathematics, and the geometry is trying complex. This is really simple what it does. And we get these sort of two products at the top, the ortho looking straight down, and the 3D model, and I've showed you some of those. There are other derived products. If you're flying a thermal sensor, you'll get that too. But that's the essence of what this thing is doing, and that's the essence of what reality is. Reality appears in a number of different products, but we'll just talk about one of them. But once we've got those derived products, we want to do this. We want to get that data out to our friends, clients, customers who are actually doing a job. This is why the drone's flying around. It's not just for fun, it's to get this done so we can view it in 2D and 3D. I've already shown you some of them on our mobile phones. More often than not these days in these extended reality applications, the games engines, the virtual reality headsets, and so on and so forth. So that's what we want to get to. And the workflow, 3 stages really. The plan and capture piece, get the drone to fly in the right area, right degree of overlap, get it done quickly, bring the right number of images back, get it into the reality engine, run that photomagnetic process, and get those products out, and then get them shared. That's the 3 steps through. Let's just go back to the first stage, just to give you a feel for it. This is the ArcGIS flight app we're seeing here. There are many flight profiles depending on what we're doing. 3 here. Top left is an area survey. Draw a box. The green lines are just like the lawnmower going up and down your lawn. That's where the drone's going to fly. Top right, 3D mission, flies around the structure 3 or 4 times, camera at different angles, so we can get the top and the sides of the building. And the bottom one, linear feature, road here, could be a river, railway line, that sort of thing. Terrain follow, really important, because we want to maintain the sensor and the aircraft at the same height to maintain that resolution and maintain the coverage. But that is the first step. Once we have done that, and this is site scan I'm showing you here now. There are 3 other products, but this is the simplest one. We upload those images into site scan, and we're seeing Lockderg again. The white dots are the pictures, so we've always got access to the original pictures. What we do then is we literally process the data. Site scan, it's low, medium, high, ultra. There's only four buttons to press. The other products have more complex sort of settings, but once it's done, we get that high resolution image that you can see there. Let me just go very, very quickly to the mesh. So this is the mesh that we're seeing here. And if I go and change the obliqueness, so this is the 3D mesh that you saw in the viewer right at the beginning. There are a number of things we can do here. We can do a profile through so we can actually see what that looks like. If we're interested in inspections, so I clicked a dot on there, and if we want to inspect that particular site, so we're interested in how stable is that monument, we can see that, and we can also go to these original pictures, and we've got multiple examples below there. And just to finish off, just to look at a slightly larger area. So again, back to this 3D scene viewer. This is Stuttgart, left, right, 25 kilometers, up and down 20 kilometers, 12.5 terapixels, a lot of pixels, 69,000 frames, 69,000 images. But what we're seeing is a very large model. Aircraft here, much sort of more sophisticated camera behind it, but we're getting resolutions on the 3D model like this. Done for the municipality. The use cases will be myriad: planning, where's the infrastructure, sort of wastewater, communications infrastructure, and so on. But I will just stop there. A real rush through, hopefully it's provoked some thoughts. So Claire, back to you.
Lovely, thank you, Mark. That was a really great insight into ArcGIS Flight and Site Scan, and it's fantastic to see what we can achieve with drones in the reality mapping space. Moving through our examples, ArcGIS also allows us to conduct analysis, collect observations, and supports inspections, monitoring, and operational intelligence. To show us what we can achieve here, I'll hand now to Arthur. So what have you got for us today, Arthur?
Thanks, Claire. So today I want to talk about oriented imagery, which is perhaps an underutilized capability within ArcGIS. So what do I mean when I say oriented imagery? Well, typically when we're talking about imagery in a GIS, we're talking about imagery that looks like this. It's captured maybe from a satellite or an aircraft, generally from a top-down perspective. And this is great because it overlays very nicely with our maps, which are also from a top-down perspective, but not all imagery is captured this way. what if we have images that were captured from ground level or images that are pointed up above the horizon line? These images are much harder to view in this kind of 2D top-down perspective. And this is where the oriented imagery capability comes in. So just by oriented imagery, I'm talking about any imagery that's not captured from this straight top-down perspective. And that could include various examples, like here we see an on-the-ground survey inspection. Here we can see some oblique drone imagery similar to what Mark showed earlier. And here we have an unusual type of imagery. Here we've got some 360-degree aerial imagery. And so what the oriented imagery capability within ArcGIS is allowing us to do is view this imagery alongside our map in the context of our map. So here we can see, as I move around the image, it's updating this little red box, and this red box is representing the footprint of what we can see in this imagery viewer over here on our map. And the benefits of this are twofold. So as we move around the image, our map is adding additional context to what we're seeing in the image, but also the image is adding additional context to our map. This is really the aim of the oriented imagery capability in ArcGIS. So oriented imagery in ArcGIS has actually been around for a little while, but it's undergoing a major transformation. And the goal of this transformation is to make it easier to access and easier to use. So that's why I want to talk a bit about it today. So if you've used oriented imagery before, you might have come across an oriented imagery catalog. And this is the way that we used to manage oriented imagery within ArcGIS. This is now what we refer to as Oriented Imagery Classic. In recent updates to ArcGIS, this new integrated oriented imagery layer approach has been adopted. New oriented imagery layers is the new way to manage oriented imagery within ArcGIS. You can see here immediately, rather than being a separate type of item, this oriented imagery layer is just part of a standard hosted feature layer within ArcGIS Online. And this is already making it much easier to manage our oriented imagery. So to demonstrate this new integrated oriented imagery layer, I've created one using some 360-degree images I took outside our Aylesbury offices. First thing to note here is that I'm just in Map Viewer. I'm not in any dedicated viewer application. And this is one of the main benefits of this new approach. It's much more tightly integrated with the wider ArcGIS system. So if I come over to the Layers tab and click on my oriented imagery layer here, on the right-hand side, you can see this oriented imagery viewer pops up. If I click on this, it brings up the viewer window on the side of my map viewer. I then click on a point in the map, it will bring up the imagery that's close to that point. And as I showed in the demos earlier, you can pan around and it will update the footprint. Now, if I look over this way, oh no, we've got a person in our imagery. Luckily, I captured multiple images from each of these locations. And we can use the integration with Map Viewer to directly edit oriented imagery layers using the edit tools within Map Viewer. So if I come down to Edit, select a feature, select my image capture point. Here's my image. And here we can take a little look at the different fields that are driving the oriented imagery capability. So if I scroll down here, these are the camera parameters that are captured when we take an image in the camera metadata, depending on your camera model, of course. And this is what's used by the oriented imagery viewer to calculate that footprint on our map. So we've got the orientation of the camera in 3 axes, we've got the field of view in both directions, and we've got the near and far distance, which is used to set the maximum search distance when we click a point in the map. What we're interested in, though, is updating this image path. So here my imagery is hosted in an S3 bucket, an Amazon AWS S3 bucket, and I can simply come in here and update the image in my URL to one that doesn't have the person in. And I'll update the name here too for clarity. Click Update. And then immediately, if I come back to my oriented imagery viewer, click on the map again, the same location, I should see that once the imagery is loaded, it will be that new image that I've substituted in there. You can see here the person is now not visible, much better. So once we're happy with our oriented imagery and our map, we can then share that in an app using the new Instant Apps integration with oriented imagery. So I come over to my Instant app. This was as easy as creating a simple sidebar app template and then just turning on a toggle switch to enable oriented imagery. And immediately it works exactly the same. I can click in my map, and on the left-hand side here, it will bring up a oriented imagery view at the point I clicked. You see it's working exactly the same. I can use this little navigator down in the bottom right to change the perspective. So if I want to view the same location from a different angle, I can simply click one of the compass directions and it will show me a different image that will face me towards the point I clicked on the map. So I've talked a bit about how we view oriented imagery layers, but how do we actually create them? Well, there's two options. One is using Quick Capture, and one is using ArcGIS Pro. Let's look at Quick Capture first. So if you're not familiar with Quick Capture allows us to design very simple and streamlined interfaces for a mobile application that then allow us to capture data very rapidly. So here I've just created an interface that just has one single button on it. And this button is set up to capture a single photo in this inspection points feature layer. Once I've set up this button how I like it, I can come up here to manage project layers, click the three little dots next to my inspection points layer, and here I've got options to enable and view oriented imagery. If I hadn't already enabled the new oriented imagery layer, it would say enable oriented imagery just here. And what that does, clicking that button within Quick Capture, it sets up an oriented imagery layer for us, and it also adds the necessary fields to our layer. So if I go back to my button, back to data, if I scroll down a bit here, all of these fields down here were added automatically once I enabled oriented imagery, and this includes all of the things that I showed earlier, so the heading, pitch, role, field of view, and these are all captured from the device, so we don't have to think about it. Come back to manage project layers. Now that I've created my oriented imagery, you can see there's an option to view oriented imagery. And this, if I'd captured some data with this application, would open up a map viewer so that I could view my oriented imagery. You'll also see here that there's an option to enable oriented imagery classic. Now, because we're still in this transformation period between the classic and the new oriented imagery capabilities, both Quick Capture and ArcGIS Pro still have the option to create classic oriented imagery catalogs. Speaking of ArcGIS Pro, let's have a look at how I created that oriented imagery layer that I showed off earlier. Using the new integrated oriented imagery tools, this was a very straightforward process. So I came down here to this oriented imagery toolbox, used the Create Oriented Imagery Dataset tool, and this sets up a dataset that has the relevant fields already in it. Can then use Add Images to Oriented Imagery Dataset to add my imagery. And I just passed it a list of image URLs from my Amazon S3 bucket, and it read from the image metadata all of these different parameters, including the camera location. Once I've got my images in, you can optionally build this oriented imagery footprint, and that's, you can barely see it, but it's this transparent green oval around all my images, and this effectively represents the coverage of your images, so the total area on the map that's visible across all your images. Once I've got my imagery layer and my footprints, sharing them to ArcGIS Online is now a very straightforward process. Simply select them in the contents, right-click, sharing, share as web layer. You can now share an oriented imagery layer exactly as you would any other feature layer within ArcGIS. And this is a much simpler process to compared to Oriented Imagery Classic, which required separate management tools add-in for Pro, which is still available, and separate tools to publish the Oriented Imagery Catalog once it had been created. Now it uses the integrated sharing tools. Another thing that's been integrated into Pro is the Oriented Imagery Viewer. So if I have an Oriented Imagery dataset selected in my contents, you can see this Oriented Imagery Layer option in the top ribbon, and clicking on this will bring up the same viewer that we have in Map Viewer and Instant Apps. Again, this is now integrated into Pro as of version 3.2, and we don't need a separate add-in like we used to use for Oriented Imagery Classic, though that add-in is still available. So there I've talked a bit about how we create and how we view oriented imagery, but I also mentioned that oriented imagery is undergoing a bit of a transformation. Now, the goal of this transformation is eventually to have this new oriented imagery capability match and eventually surpass the capabilities of the classic viewer, but we're not quite there yet. The focus at the moment has been laying a strong foundation for this new capability, and that means that some of the capabilities of the classic viewer are not yet available in the new viewer. This table breaks down some of the key differences here. So we can see, for example, Experience Builder at the moment only supports the classic oriented imagery. Capabilities that are more advanced, like overlaying vector data into your imagery, taking measurements from your imagery, viewing your imagery alongside 3D web scenes in applications. These are things that are only currently supported in the Oriented Imagery Classic. However, hope is on the horizon. Over the next few updates in 2024 and 2025, we're going to add support for more imagery types, more image hosting options, scene view integration, a new Experience Builder widget, overlay and measurement tools to this new integrated oriented imagery viewer. As well as that, there's going to be migration tools available to migrate your classic oriented imagery catalogs to the new oriented imagery layers. So if you're already using oriented imagery classic, you can stick with classic and use these migration tools to migrate to the new capability once the classic one is retired, which is thought to be targeting around 2026. If you don't need any of the advanced capabilities in classic, as I've shown today, the new integrated oriented imagery capability is much easier to use and get started with, and I recommend everyone give it a try. Thank you, and back to you, Claire.
Thank you, Arthur. That was a fantastic insight into oriented imagery and lots of good stuff packed into that session. For our final example, we will look at spatial pattern detection, and this can help us to understand the natural and built environment. Unfortunately, you are stuck with me for this one, and we're going to look at AI in the ArcGIS system. But before we do that, what AI is available today in ArcGIS? So let's start with GeoAI. GeoAI is integrated into ArcGIS, allowing us to automate data extraction and automate what would have been long digitization tasks. And then generative AI. So generative AI is enhancing our user experience of using ArcGIS. For example, we've got AI assistants performing tasks and generating GIS content for us. And a really great example of this is the Survey 123 Beta Smart Assistant that can create survey forms using simple language prompts. So looking at these two options, it seems like today for imagery workflows, we need GeoAI. And GeoAI can support us in multiple different ways with our imagery data, and more specifically, pre-trained deep learning models. We've been adding pre-trained models to the ArcGIS Living Atlas of the world for a few years now, and our collection has grown from building footprints to cover over 60 use case applications, helping us to automate what would have been those long digitization tasks. The Segment Anything model was released last year, and it was developed by Meta. And this model does what it says on the tin. It segments everything that it can see in your imagery. When we open one of these models, we will notice that the metadata has a really great description and a guide on how to use it. And you'll find this on all of our pre-trained models, and I highly recommend that you check all the requirements and recommendations here before you decide to get started with any individual model. What's great about these models is that you can use them across the ArcGIS system in ArcGIS Pro, Online and Enterprise. So they're ready for you to use today, wherever you're working. And the best part, no prior machine learning knowledge is required. So let's take a look at the results of this Segment Anything model in ArcGIS Pro. So these are the results on some high resolution imagery from our partners at Blue Sky. And we can see that it's created a lot of individual features, including road markings and even identifying individual trucks. If we look more closely at the buildings layer, we'll see that it's also identified individual components of roofs on the buildings. The traditional building footprint model would only capture one individual feature, So the segment anything model could be quite useful here for more accurate assessments if it wasn't surrounded by the noise of the other features. So let's use the deep learning tools together with a text segment anything model instead to see if we can isolate this layer from the noise. This text version of the model allows me to provide a text prompt to let the model know exactly what I'm looking for. So for this one, I'll use building roofs as the prompt, but I could equally have chosen something else, circular objects, for example, roads, and so forth. Once this model's run, we can see that it's extracted the individual building roofs only in yellow. So with this data, I have individual components and their orientation isolated from the building footprint itself to help inform a better and accurate assessment of each sloping roof component. And this particular use case could be quite useful if we were doing a solar assessment. The addition of these SAM models opens up so many more opportunities for us to use the pre-trained models that we might never need to train our own model ever again. But you know what they say never. And luckily, ArcGIS Pro has deep learning tools available to help you train your own models if you need to. So in this session, we've covered the recent advancements in the imagery space, covering all three themes: reality mapping, spatial analysis and observation, spatial pattern detection, and we did it across the whole ArcGIS system. And we really hope that you've seen something that has inspired you today. So just before we move on to our Q&A, our next webinar is on the 20th of June at 11 AM. This is part of our ArcGIS update series, and it's our summer edition hosted by our colleague Alicia Baz. And these sessions are essentially a one-stop shop for all the latest updates and advancements across the ArcGIS system, and we'd really love for you to join us. Okay, so we've now arrived at the Q&A, and we've had some fantastic questions coming through. Would anyone like to kick us off?
Claire, it's Mark. I'm just looking at Slido, and I probably get the first one.
Sure.
It was a question about sort of the quite small areas that I was showing. I think that came in before I showed Stuttgart. But just to give everyone a bit more information, Reality is the engine, and you see it in 4 of our products. I hinted at that in the sort of conversation. SiteScan is the first. It's the easiest. It's hosted in the cloud. It does data management. About 3,000 images it will do. There's next something called Drone to Map, which is hosted on your workstation, and that will do something like 30,000. So you're sort of getting the idea as you get more sort of power and the product gets more sophisticated, you can have bigger areas. But the last one I showed you, I think I gave you the dimensions, 25 kilometers across by 20. Though that's not smoke and mirrors, that is real stuff. In fact, it wasn't done recently, it was done a while ago. So that sort of answers that question. I'll stop and let another question come in.
Fantastic, thank you, Mark.
Yeah, I can probably take the next one. So top question is, can Survey 123 produce oriented imagery or just quick capture? So at the moment, it's just quick capture that can support that creation of the oriented imagery layer or catalog directly from within the app. But there's nothing stopping you taking the images that you've captured in Survey 123 and using the tools in ArcGIS Pro to create the oriented imagery layer. The main requirement is that you capture all of that metadata that I showed, so the camera orientation, the location, the field of view, that sort of thing. As long as that information is captured somewhere, you can create an oriented imagery layer from it.
Brilliant,
Arthur,
thank you, Arthur.
Do you want me to get the next one, Arthur? There's a question about accuracy. It may relate to your sort of camera in the field, Arthur, you can perhaps get that one next. But on the drone side, the question's right. The drone doesn't know exactly where it is. It could be a couple of meters out. But what I would say, I didn't have time in the briefing to say this, but that photogrammetric process, although the drone doesn't know exactly where it is and it's picking up the tie points, that whole process is creation of these matrices and these triangular models. They are then adjusted to drive the errors out. So although the drone may be quite a few meters, we don't know exactly where it is, it can produce much more accurate positioning on the model. It's the same as in construction. This is why you do surveys. What I would also say is that's with a really simple drone. if you get what's called an RTK drone, real-time telecommuting, what it's doing is there's a base station that's continually updating the drone with more accurate position information. So you're gonna get much better accuracies. And then the final piece is you can have ground control. You may have seen it where they put these markers out on the ground, and they are accurately measured and positioned. And the reality software will eye points and use them, and then you're within a handful of millimeters. Just a little bit more on accuracy as well. There's two bits to it. There's relative accuracy. This is where you've got the 3D model or the ortho, and you're measuring just on that, and that is going to be within a couple of pixels. So if the imagery is at 2 centimeters, it's going to be within a couple of centimeters. The absolute accuracy, and that's probably what you're thinking of, where we've got other data sets and we're overlaying the orthos and the 3D against other things, and that absolute accuracy is probably the first bit of the question. I'll stop there again, and Arthur, let you pick up another question.
Yeah, so the top question here is, how would you add existing imagery captured with a digital camera to create your oriented imagery data set? Now that really is dependent on the camera that you're actually using. So in my example, I used a 360-degree camera. 360-degree cameras are quite good because they tend to capture that heading, pitch, and roll information natively. And they use this because most 360-degree cameras have software that can level the horizon, which is quite important in a 360-degree image. I also showed quick capture. Quick capture uses a smartphone. Smartphones have tons of sensors in them for capturing things like the orientation and position quite accurately. And so that's why phones are quite good for capturing oriented imagery. If you wanted to use a standard digital camera, it's possible, but you'd need a lot more kind of measurement tools to measure things like the heading of the camera, the exact GPS coordinates of your imagery. It's a lot more difficult to use a standard digital camera for capturing oriented imagery. Drones as well, like Mark said, they also tend to capture those metrics, the rotation and things, because the drone needs to know roughly where it is. So similar to a mobile phone, it's much easier to get those metrics out of a drone image than it is from a standard camera image. So yeah, that's what I'd say on that. It is possible. Once you have your image, if it does have those metrics, adding imagery into an oriented imagery dataset is as simple as just dropping a list of links essentially to wherever you're hosting your image into your image catalog using that add image to oriented imagery dataset tool within Pro. If you're just using your images in Pro, those images can be stored locally. If you're wanting to share to ArcGIS Online or Enterprise, they need to be stored somewhere like an S3 bucket, like I showed. Some image hosting site just so they're publicly accessible and can be viewed within the applications. Hopefully that answers your question.
Okay, Arthur, I'll pick up two more. Yeah, Arthur, I'll pick up two more questions like I can see in Slido. The first one is about sort of permissions and so on and flying these drones. I mean, we're Esri, we make the software, but I do know a fair bit about this. We've got partners who'll give you the detail, but essentially the pilot, the person flying the drone, it needs to be qualified, needs to know what he's doing, and he will know what permissions he needs and where he can fly. I mean, there are all sorts of issues. Safety is just one of them, but also privacy. So yeah, when the guy's trained, he'll know, he should know what to do. There's also a question a bit further down on some of these small consumer sort of drones, particularly the DJI Mini 4 Pro is a little tiny one, but it's got a very good camera on it. And for whoever answered that question, yeah, flight planning, the ArcGIS Flight will not connect to that because it's such a low-level drone. But those first 3 data sets I showed you were flown with a Mini 3, so an older version of that. So it can absolutely be done. And if you've got an understanding of what the engine needs, that's all doable. There are some flight profiles that DJI have which will enable that. So I'll stop there, Arthur, let you pick up the next couple.
Yeah, no problem. questions coming in saying, can you use the oriented imagery functionality within images stored in, say, SharePoint, or do the images have to be internal? You can use images stored pretty much wherever. There's a couple of requirements though. So for at least the new oriented imagery layers, it has to have the actual like image file extension as part of the URL. So if you're hosting in Amazon, it has a .jpeg at the end. But for images stored in, say, OneDrive or Google Drive, they tend to not, because they're not really designed for image hosting. So it's best to choose a site. If you can embed your image in another application, you can use the new oriented imagery layers. If your imagery is hosted somewhere where you couldn't embed it in a web application, then likelihood is it won't work. I also mentioned this when answering another question, but if you're just looking at the images locally in Pro, the images can be stored locally on your machine. And there will also be functionality coming in an upcoming release that allows you to host the images as feature attachments on your oriented imagery layer in ArcGIS Online, which makes imagery hosting a lot more straightforward.
Thank you, Arthur. I'm going to jump in. I've got a few questions on mine. The first one is, does Segment Anything work on feeds or just actual data layers? I'm not aware of them working on feeds, and I've only used them myself in actual data layers. So I think no. And then one of the other questions in for mine is, the spatial analyst extension required for all image classification methods? So just to be sure that I'm answering your question correctly, if we're talking about image classification toolbox, then I believe you need spatial analyst and image analyst, depending on your workflows. But if we're looking at the kind of deep learning toolboxes that we used alongside those pre-trained models, that is the image analyst toolbox.
Just a bit more on that, Claire. Of course, you can do a lot of that online. A lot of these tools
you can
are
if you have
ArcGIS Online, so you've got a couple of options there.
Yeah, definitely. Good point, Mark. I think that was most of the ones for me at the top at the minute. If anyone else has others upvoted.
Yeah, I've got another question come in. So, which version of Enterprise Portal supports oriented imagery, or is it only available in AGOL? So no, it does. It is supported in Enterprise. The new oriented imagery layers are supported in Enterprise 11.2, and I'm not sure exactly which version the classic oriented imagery catalogs were introduced, but you need a version of Pro 2.3 plus, so it would be the appropriate version of Enterprise for Pro 2.3. Yeah, should support oriented imagery catalogs, but like I say, I'm not 100% sure on that one. Got any advice, please, on automation for setting up a large amount of video data stored in oriented imagery classic? So if you're using large amounts of video data, you can use the oriented imagery classic tools to import and read the metadata from your videos. So those tools are effectively scripts that will run through a list of whatever image sources you provide, including video, and read the appropriate metadata. So I would have thought the built-in management tools should do most of what you need there. Otherwise, you can link those management tools together through things like Model Builder, which allows you to chain together geoprocessing tools within Pro, or you can even embed those scripts into other Python tools that you've created in ArcGIS Pro for enhanced automation. There's a few options. I'm not really able to offer any specifics without knowing a bit more detail, but
after it's Mark, I can add a bit more to this on the video, not so much on the orientated imagery side. But I hinted at, and I probably distracted you right at the beginning of my brief, was I said we can deal with video, and it's probably a subject for a completely different webinar. But the video feed, certainly from the drones, can be fed down. We have video servers to capture and store it, but more importantly, if the sensor on the aircraft has got the right metadata, it clearly knows where it is, but this is about knowing where the camera's pointing. We can position the footprint of the video feed on the map. So what we can see is the drone and the aircraft flying around, and a box that's changing shape that's following it around. And from that video feed, we can position things from the map and stick it on the video feed, or point at the video feed and it will position it on the map. So it's a really good way of adding value to the video coming from the aircraft.
Yeah, that's a good point. So it's supported in both Oriented Imagery Classic, which gives you kind of a basic view, or the full motion video tools in Pro, and the video server, which is what you're talking about, Mark.
Yeah, but let's leave that there, everyone, because that's probably a different subject, and would spend all day talking about it. But I'll stop on that one.
Brilliant, thanks both. I think we've got time for just about one more question. I've got one lined up here. Are there any public data sets that can be used to build a digital twin, or do these need to be purchased through partners, e.g. Blue Sky? So this really depends on what it is that you're after. There are quite a few layers on the Living Atlas that might be of interest. We have the 3D base maps, 3D building layers, trees. So it really just depends on what your use case is and what you really want to get out of that digital twin. So I think that's all we have time for today. We've tried to answer the most upvoted questions. I hope you've enjoyed this webinar, and I hope that you will join us again. Thank you very much for your time. Thank you to our presenters today, and enjoy the rest of your day.